This is a video lesson for John Allison's Pulaski Tech Statistics class by Section 5.2. Recall in Section 5.1 that if we wanted to find probabilities for a normal distribution, we had to convert to the z-scores and use a standard normal curve. For instance, if we had a normal distribution with mean 45 and standard deviation 10, the normal curve for the distribution, it's a bell-shaped curve with the mean 45 and one standard deviation is 10 units. And if we wanted to find the probability that x was within a certain interval, let's say we want to find the probability that 40 was less than or equal to x is less than or equal to 50. And on our curve, what we were looking for is the area underneath the curve between x equals 40 and x equals 50. To find that, we had to convert to z-scores. So we wanted for x equals 40 to convert a z-score x1 minus the mean divided by the standard deviation, which is 40 minus 45 divided by 10. In this case, negative 5 over 10, or z1, is negative 1/2. We let x2 equal 50, and we found the z-score for 50 to be 50 minus 45 divided by the standard deviation of 10, which will give us 5 over 10, or 1/2. So effectively what we were doing was converting this curve to the standard normal curve, where the mean is equal to 0, one standard deviation to the right becomes 1, one standard deviation to the left becomes negative 1, and so our x values of 40 and 50 become negative 1/2 and 1/2 for z. So we're really looking for the probability that z is between negative 1/2 and 1/2. And to find that, in the calculator, we did second vars, went to normal CDF, we entered our lower z-score, our upper z-score, and hit enter on the calculator. And the calculator tells us the probability is 0.3829, or 38.29%. That's the probability in this normal distribution with mean equal 45 and standard deviation of 10 that the random variable x would fall between the values of 40 and 50. Your calculator, though, gives you an option to do the same thing without converting your x values to z-scores. In this case, for the same curve we did a second ago, if we want to find the probability that x is between 40 and 50, we go second vars on the calculator, go to normal CDF again. This time we're going to enter the lower limit, the upper limit, comma, the mean and the standard deviation. So for our example above, we would do normal CDF. Our lower limit would be 40, our upper limit would be 50, our mean was 45, and our standard deviation was 10. calculator, we should get the same answer as we did a second ago. And we do. 0.3829 or 38.29%. Let's look at a couple of examples. On page 254, number 18, says monthly utility bills in the city are normally distributed with a mean of $100 and a standard deviation of $12. Mean is $100 and standard deviation is $12. Part A says to find the probability that a utility bill is less than $70. So if we let X be the random variable of a monthly utility bill, we want to know the probability that X is less than or equal to $70. If we look at the curve, again a bell-shaped curve, mean is $100, standard deviation is $12. We want to know the area under the curve less than or equal to 70. In your calculator, second vars, go to normal, CDF. Here again, our lower bound is to the far left of the curve. We can't put negative infinity in, so we're going to use negative 10,000. The upper bound in this part of the curve is 70. Our mean is 100. And our standard deviation is 12. When we enter that in the calculator, that will give us the probability that an electric bill is less than or equal to $70. We get 0.0062, which is 0.62%. Part B in number 18 says find the probability utility bill is between $90 and $120. So we're looking for the area under the curve between 90 and 120, or the probability that our random variable X is greater than or equal to 90 and less than or equal to 120. We're going to go to second vars, normal CDF. We're going to enter our lower bound of 90 this time, upper bound of 120, our mean of 100, standard deviation of 12. The calculator will give us the probability, the area under the curve, the probability that a monthly utility bill is between $90 and $120. This time we get 0.74988 or 7499, so 74.99% is the probability that a monthly electric bill is between $90 and $120. Part C asks for the probability that the utility bill is more than $140. This is more than 3 standard deviations from the mean. So this percentage should be really small. This probability should be really small. So we get the probability that X is greater than or equal to 140. Again, we're going second vars to normal CDF. Our lower bound this time is the 140. Our upper bound is positive infinity. We're going to use 10,000. Our mean is 100. And our standard deviation is 12. The calculator reads 4.2911 e to the negative 4. So that's scientific notation for times 10 to the negative 4th power. In other words, that's 0.0042911, or as 0.04%. 0.04% probability that a monthly electric bill is greater than or equal to $140. So let's do another example. Let's look on page 255 at number 24. It says to use the normal distribution of women's total cholesterol levels in exercise 10, for which the mean is 197 milligrams per deciliter and the standard deviation is 37.7 milligrams per deciliter. So our mean is 197 milligrams and our standard deviation is 37.7 milligrams. Part A asks us what percent of women have a total cholesterol level less than 217 milligrams per deciliter of blood. We sketch the curve. Mean is 197. We're looking for the percent that have a total cholesterol level less than 217. So we're looking for the area under the curve to the left of 217, or the probability that our random variable x is less than or equal to 217. Again, we use the calculator, second vars, bring up the normal CDF distribution. We're going to type in our lower bound. Instead of negative infinity, we'll use negative 10,000. Our upper bound in this case is going to be 217. Our mean is going to be 197. And our standard deviation, 37.7. The calculator will give us a probability then that a woman's cholesterol level is less than or equal to 217 milligrams per deciliter of blood. The calculator tells us 0.7021 or 70.21% is the probability that a woman will have a cholesterol level of less than 217 deciliters. Part B says if 200 U.S. women in the 35 to 44 age group are randomly selected, about how many would you expect to have a total cholesterol level greater than 185 milligrams per deciliter of blood? In this case, we're looking for the probability that our random variable x has a value greater than 185. So again, we go second vars, normal CDF, this time our lower limit is 185, our upper limit we'll use 10,000, our mean is still 217, and our standard deviation is still 37.7. That probability is 0.6249, or about 62.5%. But the problem asks us, if we selected 200 women for a study, how many would we expect? We would expect about 62.5% of those. So our answer is going to be 0.6249 times 200. Which in your calculator is about 125. So we would expect 125 women out of the 200 to have a cholesterol level greater than or equal to 185.